Take the equation iron 4 sulfide plus oxygen yields iron 3 oxide plus sulfite. To balance the equation, I add 4, 11, 2, and 8. 6.62 moles of FeS2, and in the diagonal box put 4 moles of FeS2 from the balance equation, and on top of that we put 8 moles of SO2, also multiply across, which equals 212.96 divided by the bottom, which is 4, gives you 53.24. Next, you have to do the same thing with the reaction. So take 5.44 moles of O2, and in the diagonal box put 11 moles of O2 from the balanced equation, and 8 moles of SO2 also from the balanced equation on top. Now you have to multiply across, which gives you 43.52, divide by the bottom, which is 11, and gives you 3.45 moles of SO2. You have less moles of oxygen formed than you do with iron sulfide, therefore oxygen is the limiting reagent. To find how many moles of excess reactant is left over, you have to set up one more stoichiometry. Okay, so take the limiting reagent, which was oxygen, so you get 5.44 moles of O2, and diagonal, put the 11 moles of O2 from the balanced equation, and on top, the 4 moles of FeS2 from the balanced equation. Then you multiply across and divide by the bottom, which is the work here, gives you 1.98. Now we subtract the 26.62 that we started with and minus the limiting reagent, which is 1.98, which gives you 24.64 moles of FeS2. The next problem we are going to do is mass-to-mass ratio. Magnesium undergoes a single replacement reaction with hydrochloric acid. To balance the equation, we need to add a 2. How many grams of hydrogen gas will be produced from the reaction of 8 grams of magnesium with 10 grams of hydrochloric acid? So we start with 8 grams of magnesium from the equation, and diagonal we put the amount it is on the periodic table, which is equal to 1 mole, and then 1 mole, and 1 mole is also from the balanced equation, and then hydrogen 2, and 1 mole from the balanced equation equals this on the periodic table. Now you have to multiply across, which gives you 16.16, and divide by the bottom, which is 24, equals 0.67 grams of H2. Now we need to do the same thing for the 10 grams of hydrochloric acid. You put the 36.46 grams of hydrochloric acid from the periodic table, which equals 1 mole, and 2 moles from the balanced equation. 1 mole of H2 is where you're trying to get to, and 1 mole from the balanced equation, and 2.02 grams of it from the periodic table. So you have to multiply across, which is 20.2, divide by the bottom, which is 72.92, equals 0.28 grams of hydrogen. Therefore, hydrogen gas is the limiting reactant, and magnesium is the excess.